This movie is for Unit 6, Learning Target 8. We're looking at conditions for rhombuses, rectangles, and squares. Which vertices form a square, a rhombus, or rectangle? In order for us to justify our answers, we're going to need to know about properties of each of these shapes. So the first property we're going to add to our purple sheets, both on the front and on the inside, is if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So if I have diagonal AC and it's perpendicular or hits at a 90-degree angle to BD, then I know I have a rhombus. Pause the movie, add this to your purple sheets, press play when you're finished. There is a proof for that we're going to skip. Then we're going to add these two theorems. The first one says if one diagonal of a parallelogram bisects a pair of opposite angles, like this one here, then the parallelogram is a rhombus. So if it bisects angle B so that 1 and 2 are congruent, and bisects angle D where 3 and 4 are congruent, then you know you have a rhombus. The theorem 618 says if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So if you see that AC is congruent to BD, then you know you have a rectangle. Pause the movie, add this to your purple sheets both on the front and on the inside, then press play when you're finished. Let's identify special parallelograms. Can you conclude that the parallelogram is a rhombus, a rectangle, or a square? Let's explain. So in A, we can see that this line right here, diagonal, is bisecting this angle as well as this angle. What can we conclude from that? Well, we can conclude that it is in fact a rhombus because when a diagonal bisects two angles, then by that theorem, 617, this parallelogram must be a rhombus. Let's look at B. I have this diagonal bisecting this diagonal. I also have that this diagonal is 90 degrees with this diagonal. So we can say that the diagonals are congruent. So by this theorem, 618, the parallelogram must be a rectangle since our diagonals are congruent. Because the diagonals are perpendicular, then we know it's a rhombus. And the only figure that we know is both a rhombus and a rectangle is in fact a square. So we would call B a square. The parallelogram has angle measures 20, 160, 20, and 160. Can you conclude that it is a rhombus, a rectangle, or a square? Explain. Let's look at that. The parallelogram is not a rectangle or a square because angles are not right angles. It may be a rhombus. Part B says, suppose the diagonals of a quadrilateral bisect each other. Can you conclude that it's a rhombus, a rectangle, or a square? No, the fact that diagonals bisect each other is true for all parallelograms, and we notice that in our investigation on that front page. We're going to use some algebra in this problem. For what value of x is parallelogram ABCD a rhombus? Well, knowing that it's a rhombus, the diagonal BD is going to be bisecting angle B. So that tells me that this angle will be congruent to this angle. So what I do is I set it up so that the two measures are equal. And that tells me that 6x minus 2 is equal to 4x plus 8. Now, I'm going to subtract 4x on both sides, then add 2 on both sides, divide by 2, and I get x is 5. So when x is 5, I know that I'll have a rhombus. Similar to this problem, I would like you to look at this problem. For what value of y is parallelogram DEFG a rectangle? So if I know I have a rectangle, then I know that this point right here is cutting it so that E, I'm going to call it M. We'll call this point M. We'll say that EM, we know EM is congruent to MG since it's a rectangle because we know dm will be congruent to mf. So I know this 7y minus 5 is also up here, and this 5y plus 3 is also up here. So in our diagram, we know that em is equal to mg, and dm is equal to mf. So what I can do, and then I know that the two diagonals, df, is equal to eg. So I can set this 2 of the 5y plus 3's equal to 2 of the 7y minus 5's, since this 7y minus 5 is also up here, and this 5y plus 3 is also up here. So 2 of those, meaning the entire diagonal, is equal to 2 of these, meaning the entire diagonal. Distribute in, and simplify and solve. And I get when y is 4, that's when I have a rectangle. You'll be expected to do a problem just like this one at the end of this movie and answer it as one of the questions. Describe how you can use two strings to mark the four corners of a rectangle. Pause the movie, think about this, and then press play when you're ready. Okay. The answer would be to cut the strings the same length and then connect them at their midpoints. So if I had two strings the same length and I connect it at its midpoint, and this midpoint meaning it's cutting this and this congruent to this and this. Pull the strings tight and then locate the corners. These would be the corners of my rectangle. Because we know diagonals will be the same and they bisect each other. Let's go up to this one. Can you conclude that the parallelogram is a rhombus, a rectangle, or a square? Explain. Let's look at number 1. We have SO congruent to TP. So we know diagonals are congruent. Because of that, we know it's a rectangle. Diagonals are congruent. Let's look at 2. We've got this shape where the two diagonals are hitting at a 90-degree angle. Since diagonals are perpendicular, we say that this is a rhombus because diagonals are perpendicular. So you're going to need to know what properties relate to what type of quadrilateral. For 3 and 4, I want you to pause the movie and answer 3 and 4, and then press play again when you're finished. It will be the end of the movie, and these two questions, 3 and 4, are going to be the two questions that you're going to answer as part of your assessment for this movie. And that will be all.